So when we say that the graph is constantly or is changing or is increasing at a constant rate, or the graph is increasing slowly at first and then rapidly after, or when it's decreasing, all of this, what we're talking about the rate of change. Okay? So the rate of change, or the ROC, they call it ROC, ROC, is how quickly at which something is changing. Okay, so I'm looking at how quickly something is changing. Is it changing slowly? Is it changing fast? Is it changing constantly at the same rate all the time? So the ROC, or the rate of change, is often indicated by the slope of the graph. I don't know if you guys remember, we talked about earlier, or maybe like in grade 9, even 10, we talk about lines, right? We talk about the slope of the line. The slope of the line is the steepness of the graph. Is it steep, or is it less steep? Is it going down? Is it going up? All of this is represented by the slope of the line. Rate of change is the same thing as the slope of the line. Okay? That's another word for it. So the rate of change, or ROC, is often indicated by the slope of a graph. Now, I don't know if you remember, when I say slope, what do you remember? What do you think of? The line. What do you remember? What's a slope? How do you find the slope?
The step rate.
How do you find the slope of the line?
X and Y.
X and Y. What's the formula for the slope? Rise over run. It's rise over run, right? Which is the change in your Y versus the change in your X. Okay? This is like back in grade 9, 10. Okay? So the rate of change is, or the average rate of change, is the change is your rise over your run, which means it's the change in the Y value versus the change in the X value. Okay? So let's look at how to calculate that. All right. So the independent variable, remember, whatever is on the x-axis is called the independent variable. So that would be x1. And then your dependent variable is going to be y1. And then for your second point, which is point B, it will be x2, y2. So to find the slope, or the rate of change, this is what we have to do. We have to subtract y2 minus y1, and then we're going to have to divide it by x2 over x1. So this is point A, which you see that on the graph. This is point B. Okay? In order for me to find the slope, I have to do y2 minus y1. So that's the change in the y values. Divide that by x2 minus x1. Okay? Which gives me the rise over the run. Okay? So right here is the rise, and right here is the run. Okay? So let's look at an example. The altitude of an airplane. I'm given 2 points, time, that's my x value, and then the airplane height is my y value. So this is x1 and this is y1. What do we call this? x2, y2. So to find the average rate of change, I have to use the formula of y2 minus y1 over x2 minus x1. A means average.
Rate of change.
Yeah, ROC. Okay, y2 is 1400. Minus, what's y1? 2000 divided by, what's x2?
4.
Minus 0. So that's going to give me negative 600 over 4, which is negative 150. Now the difference between the rate of change and the slope is that the rate of change has a unit. The slope doesn't have a unit. When I say the slope of the line is 2 over 3, that means I'm going up 2 over 3. Okay? Slope doesn't have a unit. The rate of change should have a unit. So what would be your unit here? What's the unit for the y? Meter. And what's the unit for the x? So it's going to be meter per minute. Okay? So negative 150 meter per minute. So that means the airplane is descending. That's why it's negative. It's going down by 150 meter per minute. That's what it means. That's what my number means. Okay? So that means the height of the plane is decreasing by 150 meter per minute. Why is it decreasing? Because it's negative, right? It's negative, that means it's going down. All right. For the second vehicle rental cost, okay, I have 2 points. The points are 200, 400, and 400, 700. So they gave me 2 points with x and y for each. I'm just going to call them x1, y1, x2, y2. If I want to find the slope or the average rate of change, what do I do? What's my formula?
y2 minus y1,
Yeah,
and then x2,
over
sorry,
x2
minus x1,
minus x1. Okay? What's my y2?
700,
What's my y1?
400,
Over x2 is 400. Take away, what's x1?
200,
What would be my unit for this one? What's the unit on the y? Dollars per kilometer, right? So I have dollars per kilometer. So this is increasing by $1.50 per kilometer. Okay? So the cost increases by paying $1.50 for every kilometer you drive. Any questions about this? So remember the formula. To find the slope, y2 minus y1 over x2 minus x. Okay? So the distance required to stop a car depends on the speed at which the car is traveling. Use the tables below showing the reaction distance and braking distance needed to stop a car on dry pavement for a given speed to answer the following. So we have the speed versus the reaction distance, and then we have the speed versus the stopping distance. Calculate the average rate of change between consecutive points in each table and describe the rate of change revealed in each table. So I have to find the average rate of change between consecutive points. Okay? So, what's the formula for the average rate of change?
Y2 minus y1 over x.
Okay? So you're going to have to do y2 minus y1, right? So this is your y2 for the first one. This is your y1 over x2 minus x1. Then you're going to move to the next 2 points. So let's do the first point first. So that's going to be 2 take away 0 over 10 take away 0, which is 2 over 10, which is 0.2. Now, for the next one, I'm going to take the next 2 points, right? Because first 2, next 2, then 2, okay? Consecutive points. So it's going to be your y1, y2, x1, x2. So what would be my
4 minus 2
4 minus 2 over,
20 minus 10.
and that's going to be 2 over 10, which is 0.2 as well. What will be my next one?
6 minus 4.
Yep. 6 minus 4 over
30 minus
30 minus 20, which is 0.2.
So that's your average rate of change.
This is my average rate of change. What do you notice here?
They're all
It's constant. So when I draw this, it's going to be a line,
Oh, that's how.
right? Remember before we used to do y2 minus y1?
I was like, why are we
Y2
doing
minus
it over?
y1?
It's not always going to be the same. Oh.
Because technically x2, usually our x2 minus x1, they were 1 before. So that's why we only did the first difference. But now my x's are growing by more than 1. That's why we have to do this. And then 8 take away 6 over 40 take away 3, 30, sorry, that's 0.2. And then the last one is going to also be 0.2. So I have a constant rate of change. What would be my unit here for that rate of change? meters per kilometer per hour. Okay, so that means for every 1 kilometer per hour increase, your reaction distance is going to increase to 0.2 meter. Okay, I know this is kind of weird, but I'm gonna write, so the reaction distance will increase by 0.2 meter for every 1 kilometer per hour increase in speed. Right? So if you're gonna have to think about that you're gonna have to increase your distance by 0.2, your reaction distance by 0.2, if you are speed. If you are 1 kilometer per hour more than the norm, for you to be able to stop completely. So your distance should be a little bit farther away from the other object. Okay? Now what I want you to do is I want you to do this table here and find the rate of change for this table.